Welcome to Earth Science. Okay, Chapter 1 is an introduction and overview really of the course. There are a lot of different terms we'll be talking about. Actually, a lot of different subjects, topics will come up, but like I said, it's an overview. So here we see our learning objectives. We're going to be able to list and describe the sciences that collectively make up Earth Science, discuss the scales of space and time in Earth Science. We are also going to discuss the nature of scientific inquiry, including the construction of hypotheses and development of theories, outline the stages in the formation of our solar system, which the nebular theory explains the formation of our solar system, list and describe Earth's four major spheres. We're going to define system and explain why Earth is considered to be a system, and then list and describe the major features of the ocean basins and continents. So what does Earth science do? Okay, Earth science includes all of the sciences that seek to understand Earth and its neighbors in space. Okay, so what are those sciences? Okay, the sciences include geology, which is the study of the Earth, both physical and historical. And really, geology can be divided into physical geology, which is looking at, okay, how does a river form? How does the Grand Canyon form? Um, when did it form? Historical geology looks at topics, looks at events in relation to the geologic time scale. So if you see any questions about historical geology, look for the answer containing the geologic time scale. Okay, oceanography, that's of course the study of the ocean. Meteorology, the study of the atmosphere and the processes that produce weather. And then astronomy, the study of the universe. So you might wonder, okay, where does biology, chemistry, physics fit into geology, oceanography, meteorology, astronomy? Well, they actually are part of these, okay? Chemistry, biology, physics is really part of our science, and they're in the different sciences you see here on the screen. Okay, even mathematics. Okay, even mathematics is involved in understanding the Earth. You see here a beautiful picture of the Grand Canyon, definitely one of the wonders on our planet. Scientists still really don't know how the Grand Canyon came to be. Okay, there are theories, but still not 100%. There's a video that is called A Geologist Grand Canyon that you can watch, and I really recommend watching it. It's great footage. This gentleman is flying an airplane through the Grand Canyon, talking about some of the different features. Really encourage you guys watching it. And we'll be talking about the Grand Canyon more. But a lot of the processes that we're going to start learning about, they all come together and help to form the Grand Canyon. So Earth science is an environmental science, okay? It definitely is. Earth science seeks to study natural hazards. Those are processes that impact society. Things like smog, pollution. Earth science seeks to understand the causes and how to alleviate those causes. Earth science also seeks to understand our natural resources and how to conserve our natural resources. And we as humans definitely do influence processes on our planet. For example, you could look at a picture of some of the large cities in China, compare that maybe to a picture of Dothan, Alabama. In Dothan, Alabama, we're going to see the beautiful blue sky. In maybe Beijing or Shanghai, they're going to see smog. Okay, so we as humans definitely do influence our planet. And I mentioned geologic time because this is what historical geology focuses on. Historical geology focuses on geologic time and where things fit into geologic time. But this is a very interesting slide, and I want to spend a few minutes talking about it. So if you were to compact Earth's history into a calendar year, so if you could take Earth's history, according to science, the billions and billions of years it took for Earth to form, and compact it into a calendar year, you would see that the whole month of January would be the origin of Earth. Okay, you get to February 12th. Okay, the oldest known rocks would be formed. You get into late March. That's where the first bacteria, the first evidence of life came to be. And then you notice April, May, June, July, August, not a lot going on during that period. Okay, then you get into November, and November is when things start happening. So you start seeing animals with shells becoming abundant in November. Okay, in late November, you have plants, animals moving onto land. And then, wow, you get into December, and things that we think of as lasting for thousands and thousands of years would actually only have a very short span of time in the whole geologic time scale of Earth. Once again, things that we think lasted a very long time, if you put them in the span of geologic time, they really didn't last that long. For example, Ice Age, or the glaciers receded from the Great Lakes, that would occur at 11:58:45 seconds, okay, on December 31st. Um, by 11:59:45 seconds to 11:59:50, okay, Rome will be ruling the Western world. Okay, by 11:59:57, Columbus arrives in the New World. Okay, so you can see things that we think, like I said, last a long time, very short span in the whole history of things. And really, in that sense, time is relative. Okay, if you're looking at the whole expanse of time, um, is definitely relative. Okay. Geologic time, we've already talked about it. It's the span of time since Earth's formation. And according to science, Earth is about 4.6 billion years old. And we've gone through this concept of recent being different with the previous PowerPoint. But just know geologic time is the span of time since Earth's formation, and the geologic time scale divides Earth's history into different units. So moving into scientific inquiry, like I said, we're talking about a lot of terms because this is an overview, this is an introduction. Science assumes that the natural world is consistent and predictable. Okay, science makes the assumption that there's patterns that are there, and science tries to figure out those patterns, figure out the causes of natural events. Okay, that's the goal of science, is discover patterns and then use that knowledge to make predictions. Okay. So looking at the scientific method, usually scientists, they make an observation, they see something that's occurring, and then they come up with a hypothesis to try to explain why. Okay, so scientists make an observation, then they come up with a hypothesis to try to explain why. Now, a hypothesis is untested. Okay, if the hypothesis is tested and continues to be correct, it eventually becomes a theory. Okay, some people think, oh, that's just a theory, that doesn't mean anything. A theory is well tested and confirmed in the scientific community. Okay, and then when that theory explains a lot of other interrelated events, it becomes a paradigm. Okay, so when that theory explains a lot of other interrelated events, it becomes a paradigm. So the whole goal of the scientific method is to gather facts through observation, formulate hypotheses and theories. And just remember, a theory is well tested. It's a well tested and confirmed hypothesis. Okay. So this goes over some of the steps in the scientific method or scientific investigation that a scientist would follow. Okay. Raise a question about natural world. You do research. You collect scientific data. You construct a hypothesis that will answer the question, and then eventually develop um, observations and experiments that further test the hypothesis and analyze the data. Okay, and if the results support the hypothesis, you begin sharing it with the scientific community for evaluation and testing. Okay, if the results do not support the hypothesis, then you have to go back up to the top. You have to try again. You have to come up with a better or a different hypothesis. Okay. Now moving on to this segment, the early evolution of Earth. Okay, the term to note here is the Big Bang, which explains the formation of everything, our solar system, other solar systems, all the galaxies, all the planets. That roughly began about 13.7 billion years ago. Now, our solar system, the nebular theory explains the formation of just our solar system. Okay, and it states that the solar system evolved from an enormous rotating cloud of gas of atoms about 5 billion years ago. There was a lot of hydrogen, helium content. Okay, eventually that matter kind of got pushed together. Attractive forces started holding it together. The sun started forming. Okay, sun starts forming, starts heating up. That energy helps expand, push out other matter, other dust, other gas that eventually start forming the inner planets, and eventually the outer planets form. Okay. So Smart Figure 1.9, I encourage you guys to watch it. Please watch this video because this goes over more detail about the nebular theory. The overview, like I said, the sun started forming, started heating up, started expanding, moving matter outwards. At the same time, this whole system started rotating. So you really kind of have a balancing act there. The pushing out and then gravitational forces holding things together. And this is just a neat graphic, just looking kind of at the sky, the size and the scale of different things. So you may want to pause the video and just kind of look at this, look at different things here. The next part of chapter 1 describes Earth as a system. So it divides the Earth into different spheres. Okay, so you have the hydrosphere, which is the water portion of our Earth. Okay, so this is the oceans, this is the lakes, the rivers, and the streams. And oceans cover about roughly 71% of the Earth's surface, and they contain about 97% of Earth's water. So that means only about 3% of the total water on our planet is actually fresh water or drinkable water. So that's the hydrosphere. So remember, I think hydro means water, so this is the water sphere on our planet. Okay. And then this just showing you kind of that breakdown what I was mentioning. Roughly about 97% of the water on our oceans is, or in our oceans, is salt water, and then the remaining about 3% is fresh water. You see how that's broken down. A majority of our fresh water is actually found in glaciers, about 1.72%. Right, then groundwater is about 0.75% of the 2.5% of fresh water, and then all other fresh water makes up about 0.03%. Okay, so actually abundance of our fresh water is actually found in glaciers and ice sheets. Right, the atmosphere. Okay, so this is what we're walking around in. This is what we're breathing in. So this is the thin blanket of air that covers our planet. And of course, you start out where we are on the surface. Our atmosphere is pretty thick, but then as you go higher, the atmosphere gets thinner. That's why people who climb Mount Everest, they have to have oxygen tanks along their route, because the higher they get up Mount Everest, the thinner the air is, and makes it more difficult to breathe. And this, once again, is kind of reinforcing what I was saying. You can see with the diagram there on Mount Everest at about an altitude about 3.5 miles. That's where most of our atmosphere is. If you get higher than that, the atmosphere starts getting really thin. Okay, the biosphere. Okay, this includes all life. Okay, so this includes all life. Plant, animal, marine life, whatever is living in the ocean. So this is concentrated near the surface in a zone that extends from the ocean floor upwards into the atmosphere for actually several kilometers. Okay, so this is showing you different pictures of the biosphere. Okay, you have the rainforest and the animals that live in it, and then you have microorganisms like on the bottom of the ocean floor. You see the tube worms. They're living there by the deep sea vents. Okay, that is all part of the biosphere. Okay, the geosphere. Okay, this is looking at the solid Earth, and this is actually the largest. Now, some people might think, hey, aren't oceans larger or is our atmosphere larger? No, it's actually the geosphere. Because what you got to realize is there is a lot of Earth beneath us. Okay, so we're walking around on the crust, on the top layer, but there's a lot beneath us because we're floating on basically magma. Okay, all of the continental plates that we'll talk about, they're floating on top of magma, so there's quite a bit of distance between where we are down to the mantle and then to the core of our planet. Okay. Right, and then this is showing you some of the different layers of our planet. Okay, so the crust is what we're walking around on. The crust and the upper mantle form the lithosphere. Then below that you have the asthenosphere, which is the lower part of the mantle. Then you move into the outer core and then into the inner core. Okay, so once again you have the crust, the lithosphere is the crust in the upper mantle. Then you have the asthenosphere of the mantle. That's the part where the magma is. Okay, you start seeing magma forming the asthenosphere. That's what we're floating around on. And then eventually you get to the outer core, which is liquid, and then the inner core, which is solid. Right. Hydrologic cycle, this is just showing the flow of water, and we'll talk about it in a later chapter. But this just shows you, okay, hey, water is evaporated. Ever how much is evaporated from bodies of water eventually falls back down as rain or snow. Um, that rain or snow runs off. Some of it is taken into the ground via infiltration or taken up by plants, and then some of it eventually makes its way back into the oceans as runoff. Okay. And the last topics that we'll talk about are terms of dealing with ocean basins and continents. Okay, so ocean basins, this is of course below sea level. If, if you could walk on the bottom of the ocean, you'd be walking on the ocean basins. Okay, the crust down there is made up of basaltic rock. Okay, continental crust, on the other hand, is less dense. It's made of granitic rock. And so this is just showing you, a diagram, a map of the face of the Earth. You can see the different oceans here, and it points out some of the different features of the oceans that we'll be talking about later on, like the Mid-Atlantic Ridge, um, East Pacific Rise, some of those features. Like I said, we'll be talking about this later on. Okay. Other important terms to remember from Chapter 1, continental shelf. Okay, so this is the gently sloping platform that extends really into the sea. So if you go walk in the Gulf of Mexico, you go to Destin, Panama City, walk out in the water, you're walking on the continental shelf. Okay, it's the flooded extension of the continents. If you could walk out far enough, you would find a steep drop off. Okay, that's the continental slope. That's the steep drop off at the edge of the shelf. Then eventually, if you could go down far enough, that steep drop off would lessen, and you would find more of a gradual incline, and that's where the continental slope merges with thick accumulations of sediments. Deep ocean basins, some of the things you find in the deep ocean basins, abyssal plains, these are flat features of the deep ocean trenches, those are depressions in the ocean floor, seamounts or submerged volcanic structures. Okay, these are all different things that you would find on the ocean floor. Oceanic ridge, okay, that's a major feature of the ocean basin. It winds throughout all of our oceans. It includes the Mid-Atlantic Ridge, East Pacific Rise, and it's basically a mountain belt. Okay, it's a mountain belt that's been built up from magma coming up through cracks and cooling down and hardening. So it's a major feature of our oceans. Okay. And then a few more terms here. Mountain belts, where we talk about mountain building later on in this course. We'll be looking at the Circum-Pacific Belt, the Alps, the Himalayas. Also, in the interior of the continents, you have shields, which are flat regions of crystalline rocks, or you have platforms, which are deformed rocks covered by sedimentary rocks. And like I said, these are all terms that we'll be talking about later on. Okay, so I hope that you're going to enjoy this course. I feel like you're going to learn a lot. We've got a lot of great videos, a lot of great footage. Just take the time, set up your study plan, study schedule so that you can watch these videos. And do watch the extras that I put in, the smart figures, the videos of the gentleman flying through the airplane, flying in the airplane, taking pictures, because they are great and they provide additional resources for you to understand this material.